Hello, my dear student. Hope you are fine and taking care of yourself at your home. You know that during online classes, we are doing the chapter work and energy revision, and we are taking your Viva also from the same chapter in physics. So, today I will do a quick recap of the chapter so that you can understood the questions very easily during your Viva session. Before starting, please do like and subscribe my channel and press the bell icon button for further notification. So, let's start the chapter. Topics. First topic is work done. In this chapter we have done first of all work done. What is work done? Work done is the product of force and displacement. So mathematical formula we can write work done is equal to force into displacement. Now as you have come to know, like force is work done is force into displacement. So these are the two factors on which this work done depend. If F is 0, then work done is, if F is 0, work done is 0 into displacement. There is no displacement, then work done is also 0. And if S is 0, S is not speed, S is displacement. In 9th class in NCERT book we are writing S as a displacement. So what is the work done here? F into 0 means no displacement. Means no displacement. So work done becomes 0. Now we have come to know either force 0, displacement 0 or both are 0, then there is no work done. Now the another thing is also there, that is unit of work done. Work done as a unit is joule. Work done as a unit is joule. So 1 joule is 1 Newton into 1 meter. So 1 joule, how will you define 1 joule? If teacher will ask to you, what define 1 joule? So 1 joule is the amount of work done when 1 Newton force is applied and it displaces through a distance of 1 meter. So it is 1 joule definition. Now there is a relation between the angle also between force and displacement. When F and S both are acting in same direction, they are going like you are applying the force on a body and it displaces in the same direction. So in that case work done is positive. In that case work done is positive. And if F and S, like this is F and S, like a frictional force act on a body, so in this case work done becomes negative. Work done becomes negative. The best example of this you can learn is like when in a tug of war game, winning team is doing positive work done because they apply the force and pull out all the other players on the same direction. So they are doing positive work done and the losing team is doing the negative work done. And if S and F both are perpendicular to each other, like a body is moving in a horizontal direction, so what is the amount of work done by gravitational force on that body? So we will say that work done is 0. Earlier we have said force into displacement, if any quantity is 0 then work done 0. In terms of angle, if angle between force and displacement is 90 degree, then work done is 0. And what is the angle here? 180 degree. And what is the angle between F and S? 0 degree. It means if force and displacement have 0 degree angle, it's positive work done. 180 degree angle, then negative work done, or perpendicular to each other 90 degree, then work done is 0. SI unit we have done. So like another example, if any body is revolving in a circular path, so like we have done this earlier, if a body earth is revolving around the sun, so due to the centripetal force and its displacement, so this is the F act towards the center, so they become 90 degree. So at that time amount of work done is 0. This already I have explained you in earlier classes. So in this type of question always the work done is 0. Now the next concept is given energy. Energy is the ability to do work or capacity to do work is known as energy. Again SI unit of energy is joule. Now after that different type of energies we have done depend on their source. Like solar energy, the energy that is obtained from the sun is known as solar energy. In 9th class syllabus we are having two energies, that is basically potential energy and second one is kinetic energy. Kinetic energy. So the potential energy, as the name indicates, the energy that is stored in a body due to change in its shape, size or configuration, or due to the height. Means the energy stored in a body due to the height. Like if a body is at the ground and you raise it up to some height, so this body will store potential energy, and its mathematical formula is mgh. mgh, h is the height up to which we have raised, so, and g is the acceleration due to gravity. Now, like if here you will say, and from the here you will allow to drop the body, so its height start decreasing. See the arrow, it is coming downward, so its potential energy decreases. So whenever a body falls from top to bottom, then its potential energy decreases. Now the next is, as you can see, that kinetic energy. Whatever energy is there, they all have SI unit, joule, potential, kinetic heat, solar, whatever it is. Kinetic energy, the energy possessed by a body due to the motion of an object, is known as kinetic energy, and its mathematical formula is half mv square, where m is the mass of the body and v is the velocity with which the body is moving. So if greater is the mass, greater is the kinetic energy, greater is the speed or velocity, greater is the kinetic energy. Like if you are comparing a car and a bus moving with the same speed, so which is possessing higher kinetic energy? So you will say that truck is having higher kinetic energy because their velocities are same, so we will compare by their masses. So this is all about. Now kinetic energy we have done, potential energy we have done. Potential energy is also stored due to the change in shape. Like a spring is there, so if you will stretch the spring, which energy will stored in this? Due to the change in shape and size, so potential energy will stored in this. After that we have done law of conservation of energy. After this, law of conservation of energy states that energy can neither be created nor be destroyed. It only transformed from one form to another. There are so many examples we see in our daily life also, like when we switch on an electric bulb at our home. So electrical energy, in that case, electrical energy will change into light energy plus heat energy. So like this, many examples are there. When you will put a torch cell inside a torch and you switch it on, so the chemical energy of cell get converted into light plus heat energy. This is inside a torch, the torch we are using, so that is light energy plus again heat energy at the same time. Similarly, when you will allow a body from top to bottom, so its potential energy decreases plus kinetic energy increases. Or when it will reach to the bottom, so potential energy becomes 0. Why the potential energy is 0? Because height becomes 0, so potential, because h becomes 0 at bottom or ground, height becomes 0, so potential energy also becomes 0. So maximum kinetic energy at bottom and maximum potential energy at the top. So we can interchange this. So during free fall, in between, it have both energy, that is potential energy plus kinetic energy. So this is by law of conservation of energy. In hydroelectric power plant, we used to convert the potential energy into kinetic plus kinetic into electrical. So these are the different energy conversions that take place in our daily life. So you just go through all these examples which are given in your NCERT book. After that, we have done the topic power. Power is what? Rate of doing work is known as power. So work done upon time is known as power. Or rate of transfer of energy is also known as power. So energy upon time is also known as power. Now the SI unit of power. Power SI unit is watt. 1 watt is 1 joule. Work done unit is joule and time is second. So 1 watt is 1 joule upon 1 second. Now 1 horsepower, because sometimes we need commercial units also, 1 horsepower is 746 watt. So this is a MCQ relation, you just go through it. Now commercial unit of energy. Commercial unit of energy. That is, from this formula you can see energy is multiplied into power. So power into time. Power into time. So that is kilowatt into hour. So it is kilowatt hour, not per hour. Many students are telling kilowatt per hour. Not per hour, it is multiplied. So commercial unit of energy is kilowatt hour. Now the next is relation between this kilowatt hour and joule. So 1 kilowatt hour is 1 kilowatt into 1 hour. So that is 1000 watt into 3600 seconds. So that is 36 into 10 raised power 3 or 2, 5 watt into second. So 36 into 10 raised power 5 divide by 10 multiply by 10 into joule. Because just now I have told to you 1 watt is 1 joule upon 1 second. So when you will multiply watt into second, so it becomes 1 joule. So that's why watt into second I have written joule. So divided 3.6 into 10 raised power 6 joule is this. 1 kilowatt hour is equal to 3.6 into 10 raised power 6 joule. So this relation is asked many times in the paper as a MCQ question. If you are telling 36, so tell 10 raised to the power 5, and if you are telling 3.6, then you have to tell 10 raised to the power 6. Very carefully you have to see in the paper कि 36 is given or 3.6 is given. If 36 is there, then 10 raised to the power 5, and if 3.6 is given, then 10 raised to the power 6 joule is there. It is a maximum important question. This is because in MCQ 1 mark relation many times and this is also called commercial unit relation with SI unit. Kilowatt hour is commercial unit and joule is SI unit. So this is the relation between commercial unit and SI unit. So today I have covered the basics of the chapter, means full chapter in the unit forms. So just do practice for all this. Next videos we will do some derivations for the exam point of view, and this is you can go through and just again read your NCERT book also for your Viva session. Thank you and have a nice day.